Let's get this done, please. Now it says consider the diagram below with masses M1, M2, and M3 hanging over a free moving pulley, full stop. Suggest a direction for the motion of the masses and use the information to I. Resolve the tensions and acceleration in the string II. Find the numerical values of tension T1 and T2 and acceleration A in the string if M1 equal to 0.5 kilogram, M2 equal to 1.5 kilogram, and M3 equal to 4.5 kilogram. Take gravity as 10 meters per second square. How do we do this? First of all, please help me recall M1. M1 we said is 0.5 kilogram. M2 is 1.5 kilogram. M3 is what? 4.5 kilogram. So what's the direction here? This way, I mean? To go this way. Now, if you ask to suggest a direction, what do you see? What would you write? It will go this way. It's called what there? Clockwise direction, please. Suggest a direction. Usually it should be either clockwise or what there? Anti-clockwise. It becomes what there? A clockwise direction. Next up, try to get out your free body diagram. For this one, obviously I will have what here as what there? M3G. This one becomes what there? M1G. So M1G here, M3G. This one goes up, I mean? Yes. Yep. That's T. Let's call this T1. This one is going this way, I mean? So this force, look at this. This force should be dragging this way. I'm calling this T1. Now observe that this string starts here and stops here. A second string starts here and stops here. So I'll have my T2 here. Look at me. T2 will go in what direction? Is it to my right or to my left? Right. To where? Right. T2. What means direction? Right. For T2, right or left? Yes. Now hang on. Listen. Look at this. I have this stuff here. Let's say these masses. Let's say these masses are quite light, such that I can hold them up here. Now, if I hold this string here, question: would they move? Yes. Listen. I'm saying that let this be light masses that I can actually hold. If I can hold this rope here, so that if I hold this rope now, this mass will not move. Alright? If I can hold this rope and this too does not move, question, the string, the tension here, will it be acting in the same direction or opposite? Opposite. So it becomes an opposite direction. So T2 goes this way instead. That becomes T2. Please take note. Opposite. For this one, look at this. For this one, coming down here, I have what there? M1G, I mean? Yes. So if I have M1G acting here, what should come here? T2. Now see the correlation. See the way the two M1s are pointing at each other. This one too is pointing at each other now. If you see the diagram, they give the equation there. If you check the diagram, the equation, they indicated this. And this is how they do it. But I'm just saying, in case they did not draw it, you should know what to do. That's a good thing. Let's draw free body diagram. Let's draw a free body diagram. Let's start with this for M3. For mass M3, what do I have? I have this one here. This becomes this. This is M3. For M3, coming down here, I have M3G. becomes M3G. Going up here, I have T1, so it becomes T1. Alright, get sum of forces. The sum of force 3, that's force of mass 3, is equal to, don't forget, direction is this way, so it's coming down like this. Observe these two are moving the same direction. So this one becomes positive. So this one becomes positive, yeah? M3G, this one is in opposite direction, becomes negative. Minus T. So I have this. So T1, so I have this. Alright, but we know that the sum of F3 is equal to M3A. The sum of F3 is given by this. That's M3G minus T1 is equal to M3A. Call this first equation. Let's talk about the mass 2. For mass M2, we have this one here. For mass M2, I have this is M2. So M2, I have T1 here. That becomes T1. This way, I have T2 this way. Alright. For this case now, of course, my diagram is going this way. So M2 will move this way. Alright, so my direction is this way. If I take the sum of F2, that will be equal to, this one moves in the same direction. So T1 is positive. Positive T1. T2 is moving in my opposite direction. So it becomes minus T2. But we know that sigma F2 is equal to M2A. Okay? Put this value here. I have T1 minus T2, that's sigma F2, is equal to M2A. Here's my second equation. Let's consider this mass. For mass M1, I have M1 there, this way. This becomes M1. Coming down here is M1G. M1G, that's this one here. Going up is T2. So I have T2 going up here. If I do the sum of forces here, first of all, note that since this system is going this way, that means M1 is going upwards. So you can go in the clockwise direction. So this way, that means I'm having this as the upward force going upward. M1 is going upwards. So if I get the sum of force 1 is equal to, this is going in the same direction as the motion. So it becomes positive T2 minus, this is going in the opposite direction. So it becomes M1G. So I have this. Alright, but we know that the sum of force 1 is equal to M1A. This value is this one here. So it becomes T2 minus M1G is equal to M1A. Call this equation 3. Alright, so I've got to my 3 equations. Next up, let me recall all 3 equations. Recall all 3 equations, please. Give me equation 1. What do we get there? M3G minus T1 equal to M3A. A. Here was my first equation. Give me equation 2. What did I get there? T1 minus T2 is equal to M what? M2A. Here's my second equation. From the third equation, I have what here? T2 minus M1G is equal to M1A. Call this equation 3. So solve these three simultaneously to get A. How do you do that? Start with any of them. Start with any of them, please. Which do I start with? From which of them? So you can start with this. Start with any of them if you want to. But I think this one is more convenient. From equation 2, I have T1 minus T2 is equal to M2A. Let's take T1 substitute to the formula. T1 is now equal to this one here. M2A. This one comes and becomes what there? Plus T2. Next up, I'll put this value into this one here. So I'll put T1 into my first equation here. That becomes M3G. We had minus T1. This minus T1. What's T1 there? M2A plus what? So this is now T1 is equal to what there? M3A. Put T1 here becomes M3G minus T1 is this value. So this replaces this here. I have this is equal to M3A. Expand this. I'm having M3G minus M2A minus plus minus T2 is equal to M3A. Alright. You can get T2 from here. Now look at this. Let me make it easy. Look up. Here's what I'll do here. This is minus T2. Take it here, it becomes what there? Plus T2. Take this one here instead. So I'll now be having M3G minus M2A. This one comes and becomes negative. Minus M3A. Minus comes and becomes what there? Positive T2. So I have this value. I will now put the value of T2 into my final equation 3. From 3, I have that T2 minus M1G, that's this, is equal to M1A. Put the value of T2. T2 is now all of this, so T2 becomes M3G minus M2A minus M3A. Here's the value of T2, then minus M1G is equal to M1A. Right. So T2 is now this. Expand this becomes M3G minus M2A minus M3A minus M1G equal to M1A. So take all the terms having A. So it has A, so it has A. Move them over here. So I'm having M3G, this one here, minus M1G is equal to M1A. This one comes over here, becomes plus M2A. This one comes when it becomes plus M3A. So I have this. Of course, factorize the A. This becomes M3G minus M1G is equal to, factorize A out of this becomes M1 plus M2 plus M3 all into A. So I have this. Alright, so what this up now? I'll now divide by this. So divide by M1 plus M2 plus M3. So it becomes M3G minus M1G all over this M1 plus M2 plus M3 is equal to this one here. That's M1 perhaps in bracket M1 plus M2 plus M3A all over M1 plus M2 plus M3. So this will cancel out this and left with A. That means A is equal to M3G minus M1G all over M1 plus M2 plus M3. So I have this. That's what you see. So we've done the first part, which is resolve the tensions and acceleration. So from here you can get T2 as being equal to this, or whatever. Hold on please, hold on. Look at this, from here, it's clear that T2 is equal from here. T2 is equal to what there? Next up. So I've resolved T2. Please look for an equation that can help me resolve T1, please. Look for an equation that can help me resolve T1. Equation 1. Which one has just one? Like has only T1? Which equation? Equation 1. From 1, what do you have there? Sorry? M3G minus T1 M3A. Let's get T1 here. Simply move T1 here, it becomes positive. Move this here, it becomes what there? Negative. So I'm having M3G, so it comes here, minus M3A is equal to T1 minus comes here, becomes what there? Alright, so this is the expression for T2. Here is T1. And this is the expression for acceleration. We've got all three. We've got all three. Right. So from here, if I substitute values, I have that A, acceleration A, let's bring it here. A is equal to M3G. M3 there is 4.5. So 4.5 M3 times G. G is 10 a bit or 9.8. 10 minus M1 0.5 into G. G is 10 all over M1 0.5 plus M2 1.5 plus M3 4.5. So A is equal to, this gives you 45 minus, this gives you 5 all over, this gives you what? 6.5. So here is equal to 40 all over 6.5. So A is equal to what value? 6.15 units meters per second square. Alright, so we've gotten this A. Let's get the tension. For tensions, let's start with T1. We have that T1 is equal to M3G minus M3A That's this. T1 equal to M3G minus M3A. In this value, M3 is 4.5, so 4.5 into G is 10 minus this 4.5 into A. A is 6.15. If I multiply this, I'll have 45 minus, give me this value please. Point what? 0.68. Please subtract this. T1 is equal to what? 17.32 units. Newton. Let's get T2. Also, let's get T2 from this equation here. It seems that T2 is equal to M1A plus M1G. That's equal to M1 is 0.5 times A. A is 6.15 plus M1 0.5 into G, 10. This is equal to this value is 3.075 plus 5. So T2 is equal to what then? 8.0 in Newton, I mean? Alright, so this is how you solve this question, right? Alright. So this is how you solve this question.